Okay, so I've got a new headset, and today I'm going to go over this assignment titled Flange Stop. This is pretty comprehensive. This is about as difficult a project as we have done. So it would help to obviously maybe have a printed drawing in front of you if you're able to do that. I'm going to start new part. Make sure I'm in inch here. And I'll start from the sketch. The orientation and the origin don't matter. I'm going to, for this one, I'll start with the line function. And I'm not going to start on the part origin. I'll just start off the part origin. And I am not going to make the fillets. I'll make the fillets on the bottom. I'm going to start with again, the profile. And I think on this one, I'm going to make the slot like this and actually make just the rectangle like this. I'm going to go ahead and use the circle function to start. This might not be the best way to do it, honestly, because I'm going to have to trim this up. So we'll see, and actually I'll put another circle in there as well. So just like that, looks pretty good. And I'll use the sketch fillet function. The radius is 205 on the drawing. And I just select two lines. And that's pretty good. Now, I probably, even before I used the sketch fillet, I probably should have smart dimensioned the overall length here as 2.5. Because now it's going to shrink a little bit. What I'll do, it's not too bad, so let's do it this way. I'm going to do it, dimension the overall height as 3 inches. And then I'll go back in, and even before I move these lines, let's dimension these diameters. This is 0.375 times 2 is the diameter. This middle one is the diameter. Oh, I think I select the same one. This is incorrect. This is 0.5. Well, I guess it doesn't really matter which one you're selecting. This one is 0.375 times 2. So 750. And then I have the overall height, the overall width, and then escape out of the dimension tool. And then I'm just going to drag this rectangle over and this line down. And I'm going to go ahead and make this line and this line collinear. And I'll add a center line from this midpoint here. And I'm just going to put it all the way up the length of the part. I will smart dimension this line length. This is a vertical line. On the drawing it's 250. And then this is 1/2 inch. And then to center the slot, I'm going to select this midpoint, hold Control down, select my center line, and make those coincident. So this is pretty good. This is kind of all I need, I believe. I am going to trim this up, though, before I fully define this. Because, well, I think it will actually define okay if you don't trim it, but let's do this trim first. This could be a little problematic, so let's see. In the power trim function, I'm going to drag, and you can even kind of look at the drawing and see what is the open area. This is open. This is open. And then these two lines also do not exist. Now I'm looking at this, and the sketch relation were eliminated on as far as where this center mark is. And you can see I'm moving this around, and actually this center mark seems to not move from this line, but this line was moving. So I'm going to select this line and make this a vertical line and see, will it still move? I think it's pretty good. The only other thing though is it did seem to change the size. I thought I had a dimension in there for the overall width. So let's add that again. From this edge to this edge was off the drawing 2.5. And now down here this looks a little wonky. Why did this move? This makes no sense to me at all. Let's add this arc and this line as tangent. And this was equal radius based on the sketch relation. Its dimension here and both of these have tangency. So let's do a little screen fit again. I'll move these dimensions down so there we can kind of see what this looks like in a better screen fit. Maybe not. Okay. So from here, I will locate this on the origin to define this. And let's see, if I select just this midpoint and this point, and then I'm going to make these coincident. So it's still underdefined. So as far as this edge goes, and this is going to apply on the midterm as well. This center mark, hold control down, and I'm going to, this center mark and this line, these need to be coincident. And it's this arcs, these arcs are still blue, they're still underdefined, and I can, the diameter is defined, but if I can move these up and down, you can see that this center mark also moves. So I'm going to add another one. It's the same as this coincident point, but I'm going to add it coincident to this top line, top horizontal line. So I'm going to select point, control point, and make these coincident. So now it shows down here as fully defined. So the midterm has an issue like this, maybe even more than one. I think I've got a concave arc, a cutout here or on the other side, and then another circle coming off where the center mark has to be tangent with this edge and this edge. There is what's called it's the position is the location of this arc and this arc is implied. They use the term implied, but you can see on the drawing that this center mark does line up with this edge. And if you actually take your drawing, you can fold the bottom edge of the drawing perpendicular to the side edges along this, where these two lines are collinear, and then it will line up with this center mark both vertically from this edge and then horizontally from this edge. I think I spoke a little bit about implied 90s. It's not necessarily implied in this case because it actually shows the center mark, and the center mark does, line up, and that's how it's positioned. This particular feature, both of these features, this inside hole and this outside arc, are positioned based on the center mark lining with the vertical and horizontal edge. Okay. So this is fully defined. This looks good. I'm going to actually make sure I have my summary information in here. I'm going to title this Flange Stop. And I'll just extrude from here. Let's features extrude. It shows a part thickness on the right side at 0.45 and done. Now let's do a sketch on this face, and I can do a rectangle. Let's do a center rectangle. I think I can get away with a center rectangle here. I'm going to dimension this from, I'm not going to do the line length, because if I do the line length, I'm going to add the fillets as sketch fillets. So I'm going to dimension it from one line to the other line, not point to point, and not line length, but edge to edge. 1.25 off the drawing. And then the same thing here. Instead of dimensioning off of a line length, actually it would be this line length, I'm going to dimension off of this edge to this edge. And this is shown as 1.25. And then I'm going to add a center line or a construction line here from this midpoint. I'm going to make this construction line, this edge, and this edge symmetrical. So it is constrained now. I have two dimensions and I have this one sketch relation on it that makes this, I can't move it side to side. It's constrained side to side, but it can still move up and down. So there is another smart dimension from this bottom edge of my base to here is 0.5. And that looks pretty good. Now, this is fully defined. I think I had an issue with my recorder. I hope I didn't. Okay. Oh, come on. This thing. Okay. Yeah, it seems to be recording. So, I'm going to add the sketch fillet here, and it's a radius of 0.25. I think I dimensioned these edges a little different. It's asking me to enter entities to fillet. I'm going to fillet. Can I fillet the whole profile? Oh, edge to edge, edge to edge, edge to edge. Excuse me. Edge to edge. 4 fillets. That looks good. You can see it added all of these tangent points, the dimensional size, and it maintained these dimensions here of the size of the rectangle. Escape, so I can kind of move these out here. So it maintained these dimensions. And this looks pretty good. Now, for this cutoff, we've done this before. We're going to use a draft cut. So this is, again, fully defined here. In sketch mode, I'm going to select Features, Extrude Cut. The preview looks pretty good. It goes down through the extension. It's not blind. I'm just going to say through all. I'm going to turn on draft. This is the toggle on and off for draft, if you remember. And then The drawing shows 25-degree draft. So the preview looks pretty good. I'm looking at this, and I'm going to say yes. But on this particular one, you can see this 1/4-inch fillet, or this 1/4-inch radius, drafted down. You can see here that there is a little bit of a fillet here on the bottom, so it doesn't come to a square corner. So it does match what's in the drawing. If I go to a different view, let's go to, is it the top view? You can see, and maybe even in different, try this one. You can see that it does match the view, the front view of the drawing. And that kind of gives you a real hint. It could be, if it doesn't match, you've got to be careful, because this could be your part thickness is incorrect. So there's other issues that could affect that as well. Okay, so I'm going to go back and change my display to shaded here. And then I'm going to add some more. Let's sketch again on this face. And I'm going to, let's actually not use that one. I'm going to get out of that. I'm going to use the hole wizard for this. So I'm going to escape. I'm going to exit without saving. So back to where I was. I've got my base sketch. I've got my cutout sketch. And let's use the hole wizard on these. You could actually do these in a sketch, but you'd have to do multiple sketches, and it seems a little, I don't know. It seems a little more, like a little more work. I'm going to go to Features, Hole Wizard, and then it shows a counterbore symbol, and it shows a diameter 140 through. The counterbore diameter is 250 thousandths with a depth of 200 thousandths deep. So I'm going to select, I think it's selected now on the hole. I'm going to select the counterbore hole, and the default goes to a threaded fastener, like they call it a binding head screw. I thought a lot of times you'll use a socket head cap screw. But I'm going to make a custom one here. I don't think any of these standard fastener sizes are going to work. So I'm going to go down here and go Show Custom Sizing. I'm going to turn on the custom sizing, and this shows the through hole diameter. Gives us a little picture, and it shows with the tooltip over this picture, it says through hole diameter. I'm going to go 140. Again, that's the diameter. The counterbore diameter, what do they call it? Yeah, counterbore diameter is 250. And the counterbore depth is 200. And the end condition here, this applies to the through hole. No countersink on this. No far side countersink. So I'm going to turn off the countersink option. Make sure you turn that off, because I will mark you down. I don't want to see that within your part. Unless it's really tiny, like a 5/1000th or something. But for the most part, I wouldn't put that in there in my design or in my drawing. So from here, this all looks good. The type, the custom sizing matches the call out on the drawing. I'm going to select now the Positions tab, and it's going to be on this face. And once I select the face, it's going to give me this sample here. And I can actually go in and wake this up here. Again, if you bring this, you should be able to drag this around this edge and wake up this center. And then I can make that coincident. I'm going to put another one over here. Same thing. I'm going to bring this along this edge and wake up this center mark. And then these, I don't have a reference. And I can get to here and I can get to there, and they're equal to each other, but I still have to go in. I'm going to say yes. I still have to actually go in and open the sketch 4. So I'm going to edit sketch 4. These two bottom ones are defined, and I need to just add a smart dimension from point to point. Off the drawing is 2 inches in this direction. And then in this direction, actually I think I'm okay if I just make this, well, let's see here, this point and this point, 0.5 and 0.6, I'm going to make these horizontal. It's still blue here, and this point, hold control down in this point. It's weird because it didn't show that as being selected when I was clicking on it as vertical. I'm going to say yes. And I'm not sure why. I can move this up and down. I'm going to make this one and this one vertical. There. So I didn't add another dimension. I didn't add this same dimension. I just made these horizontal or vertical to these other defined hole positions. So this looks pretty good. I'm going to say yes. And sketch 4 of my hole wizard is defined. So that looks pretty good. Again, I'm not going to mark you down however you want to make these. If you want to not use the hole wizard, that's fine. I suppose you could have done this with the base sketch. We could have added these holes with the base sketch and then maybe added the counter bores as another entity, like another cut entity as 4 extruded holes based on the through holes from the base sketch. So that's another option. So this looks pretty good. These are all defined. I'll go ahead and save this before I get too deep into this. Let me save this as last name, first initial, Flange Stop. And let's do the slot on the side. I'm going to start with a sketch on this face, and I'll use the rectangle again, the center rectangle, like this, and I don't have filleted edges on this, so I can actually just use the smart dimension for the width of the slot. And let's see, where is the width of the slot? It's here somewhere. On the right side view, it shows 1/2 inch, and then this line length is 0.125. There are linear dimensions from this point to, can I get to this edge? This is 1.105. And then I'm going to add a center line. It shows a center line running through the length of this part. And this is symmetrical. I can actually do another different way. I can make this midpoint and this point, or this line, coincident. So I can't move that. Let's see, I can move. Oh, the slot isn't connected. The center line isn't connected to, which is kind of weird. So I'm going to go back in and make this point and this midpoint coincident. There. I'm not sure why that wasn't coincident to begin with, but that defines the location of the slot. So from here, this all looks well and good. I'm going to change this again just so you see the dimensions accurately here. Let's go to File Properties. No. Settings. Document Properties. Dimensions. Let's go to 3 place decimal. Okay, and now you can see these dimensions do reflect exactly what's on the drawing. This again is fully defined on this sketch. So I'm going to select Features, Cut, and through all, I'm done. So that looks pretty good. This is exactly what we're going for. It's cut through both sides of the slot. And another way to view this, and you want to do this on everything you make, you want to go in, change your view orientation. I'm going to show hidden lines shown. And really look at this. Does it match visually what you see on the front of the drawing? Of course, this one doesn't have the dimensions there, but this is how you're going to get used to seeing the part, a 2D representation of a three-dimensional part. I'm going to change the view orientation again. Let's go to this view. What about this view? No, not that one. Let's see. Front, right, bottom, front. This one, the right side view looks a little wonky because if you notice the way I did the original view is not top. So, you know, the default orientations do matter as far as the default views go. So, as now if we've gotten a little more advanced and you're more comfortable in the software, you can start thinking about where do you want to start for your default view orientation. What default plane do you want to start with? So when you go to a different view orientation, it gives you exactly what you need. Now, I don't necessarily need this to be a particular way because I guess I can always just move my drawing and look at it in relation to where my drawing is. And this looks pretty good. So, I have one last thing left here to do, and that is the threaded holes. And I'm going to use the hole wizard for this as well. So from the Features tab, I'm going to select the hole wizard. And let's select the straight tap. Keep the custom and apply them to the new hole type. I'm going to say this doesn't really matter because I'll just reset because I'm going to change this anyway. It will be, I will say bottoming tapped hole. And the hole specification on the drawing, I don't even need to show custom sizing, is going to be the 1228. So I'm just going to select that. It does show 0.375 full thread. Oftentimes you won't even see full thread. It'll just say 1228 UNC-2B 0.375 deep. And when it gives you a thread call out and a depth, that depth applies for the full length of the thread from the top of, in this case, this face here. So let's look. Dun, dun, dun. It should have a depth here. Oh, the depth is the default. Let's see. Yeah, it says through all. So once I select the blind, it gives me options for the depth, and you can see this shows the hole depth, and it should, what does it say? Blind hole depth. And this should say thread depth, or it says tap thread depth. So this value is going to be 0.375. And when I press enter, this will probably change. See, it changed from 0.54 to 0.48. So the custom sizing as far as the diameter and the threads doesn't change. But the end condition for the default depth changed. So it's highlighted there in yellow for this. So this looks pretty good. This is for the display. It'll display with the tap drill diameter. It'll display with cosmetic thread. Or you can actually show it with the thread removed. And sometimes if you have a countersink or something, this might help you. Or maybe it's violating some other edge or something. So this might, you can use this remove thread to help you troubleshoot any issues with the fit. I'm going to go to, this all looks good. Again, this is straight tap. I selected the 1228. I did change to the specified thread depth, which changed the blind hole depth as well. And then really either one of these is fine. The tap drill diameter, you probably don't want to use the remove thread. If I were to use this professionally, I might use it again to troubleshoot, to look at the image in different views and see if it violates any other features. But then I would not save my part like that. I would save it with one of these two options. So now this all looks good. The type, so I'm going to select positions on this face. And then I'll put one here and one here. I'm going to say yes. And then go back in and edit the sketch. And it's going to be, I think I have to do 2 center lines. Let's do a center line here. And let's do another center line here. So I'm going to make this whole location and this center line coincident. And this whole location and this whole location as vertical? No, horizontal. Uh-oh. Let me go back. If you're not sure if you're in horizontal view or not, you can do it this way. Let's go normal 2. Normal 2. How about here? Normal 2. Okay. So now I'm normal to the sketch that I'm in. I'm going to select again Control, point 1 and point 2, holding Control, selecting both points. I'm going to make these horizontal. Now, this point, hold Control, select these 2 points and the symmetrical line and make them symmetric. The only thing missing, they're still blue, they are constrained. I can't move them side to side, and they move equidistance in and out from symmetrical to this line. So there's a smart dimension from point to point that will be constrained as a horizontal dimension. Off the drawing, it is on the left-hand side, 1 inch. And done. It shows now down here fully defined. I'm going to say yes. And that looks pretty good. Dun, dun, dun. Did I? The cosmetic thread is not turned on. Huh. Let's try it this way with like a little bit smaller that way. The other way to look at this, so it doesn't matter as far as the view. I think, where did we have that view? Cosmetic thread turned on. I forgot where that was here. Just make sure it's shown within your feature design tree as a 1228 tapped hole. Now, the other thing, now that we're done with this, go back into this view. Let's go back into the hidden line view and then look at the front view again. And it shows a pretty good preview. It's a little bit different in the drawing. So if I actually go back in, let's see if it appears different if I go back in and select. It doesn't display any different. What about this way? Does it display different? If I edit the feature and then do this. Yeah, that shows it with the dashed lines with the threaded material removed. But if you go to change the display style to the shaded, it shows it as a larger hole, which I don't particularly like. I would say leave it like this. I'm done. So this looks pretty good. Oh, it does not look good. Oh yeah, it does. It's weird because when you rotate this, let's see if we can do this. If you rotate this, it looks like the bottom of the hole is shaded gray. Do you see this? And that is the shade from the part. If you flip it over, it shows the background is white. So those holes are through holes. So I'm not sure. It's a little bit of a graphics issue there that I'm not a big fan of. I wish it would show the bottom of these holes as white and through. All of my sketches are fully defined. I've got the correct file name. With my name start at the beginning of the file name. I have the summary information in there. Your midterm will be pretty similar to this. The only thing I think on the midterm is I have you do, there's holes on it, but there's no requirement to do the whole wizard. So this one is not in the book. If I didn't mention that, sorry. PDF drawing is available. And again, if you have any questions, let me know. All right, thank you.